A power station outputs 500 joules of useful energy from 2,000 joules of fuel. What is the efficiency? Lock your answer in your head right now because this exact calculation exposes the painful mistake that destroys Cambridge physics grades year after year.
So are you going with A, 0.25%, B, 25%, or C, 400%? Have you picked one? It looks incredibly simple, right? Just a quick, easy division, but I promise you the examiner's trap is already set. Here is a frankly terrifying statistic for you. 42%. That is the shockingly low percentage of students who actually score full marks on this deceptively simple question. Less than half of the students sitting this paper walk away with full credit. Why? Well, it's not because they don't understand efficiency. It's because they fall directly into the mechanical traps hidden deep within the Cambridge mark scheme.
Let's dive straight into Section 1, the classic one-mark mistake.
Look, we really need to talk about why ordinary revision fails. You can spend hours highlighting textbooks, but if you ignore the lethal traps that examiners actually set, that revision is practically useless. You aren't just being tested on your knowledge, you're being tested on your precision. Securing a quick win means systematically, ruthlessly eliminating careless errors. The 3 absolute worst offenders: missing units, like completely forgetting the percentage sign on an efficiency calculation, rounding your numbers too early before you reach the final step, and totally confusing useful energy with wasted energy. If a question gives you the wasted energy, but the formula strictly requires useful energy, and you just blindly plug that number in, you lose the mark instantly. No debate.
Moving into Section 2, we need to build a top-band answer framework.
To stop dropping those easy grade boundaries, we have to move past just knowing the physics and shift into proving it to the examiner. Now, in just a moment, I'm going to reveal the exact examiner clue that flips this entire topic on its head, a literal hidden signal in the text that tells you exactly what they want to see. But honestly, first, you absolutely need the foundational framework that makes that upcoming clue completely obvious. Without this, you're essentially just guessing in the dark.
All right, here's the master framework you must use for every single structured response to guarantee top band marks. Step 1, identify the concept. Step 2, extract the evidence or data from the prompt. Step 3, apply scientific reasoning to connect that concept to the data. And step 4, this is the real game changer, use examiner wording. Please don't use your own casual phrasing. Use the exact technical terminology the syllabus demands. If you follow these 4 steps sequentially, you literally box the examiner into giving you full marks.
Let's take this framework into Section 3 and decode Sankey diagrams. We are going to apply this exact framework to one of the most visual parts of the syllabus, Sankey diagrams. Constantly intimidate students because they look messy and complex, but they are actually a massive opportunity for free marks if you know how to decode them. Here is the textbook definition you need. A Sankey diagram is a visual representation of energy transfers where the width of the arrow is directly proportional to the amount of energy. You need to memorize this exact definition because the phrase proportional arrow width is exactly what the mark scheme demands. If you just casually write, the big arrow means more energy, you get a 0. You have to say the width is directly proportional to the amount of energy. Using this proportional breakdown, you can pull the exact evidence required for Step 2 of our framework. Imagine this breakdown drawn out as a Sankey diagram. You'd have a massive 70% arrow dropping downwards representing wasted thermal energy and a much thinner 30% arrow pointing straight ahead for the useful electrical output. When you see this, your brain should immediately quantify the data. The input was 100% and the conservation of energy is visually proven right there by the actual widths of those arrows.
Which brings us to Section 4, electricity generation traps.
Let's escalate the stakes a bit by applying our framework to a multi-mark example involving power stations. Electricity generation is a classic long answer topic, and it is an absolute minefield for vague student answers. This table breaks down the specific scientific reasoning you need and exactly where students usually drop vital marks. Look at hydroelectric. The transfer is gravitational potential energy to kinetic. But the common trap? Students just write, water creates power. For coal, the transfer is chemical to thermal, but people constantly forget the crucial intermediate step of heating water to steam. And for wind, transferring kinetic to electrical, the fatal error is ignoring the phrase turning a turbine. You absolutely must state the specific mechanism of the transfer.
And listen, that brings us to the most critical quote of this entire topic. Energy cannot be created or destroyed, only transferred. Never, ever forget this golden rule of Physics 0625. I really cannot stress this enough. Writing that a power station creates energy is an instant, non-negotiable 0 on the mark scheme. Power stations do not create anything. They convert and transfer energy from one store to another. Always use the word transfer, never create.
All right, time for Section 5, the Spot the Error Challenge. Let's test your examiner vision. Look at this incredibly common, flawed student response. Water makes the turbine spin and creates electricity. I mean, it sounds right in conversational English, right? But in Cambridge physics, it's severely lacking. Now look at the improved top-band framework answer. Kinetic energy of water transfers to the turbine, inducing electrical energy. Notice how the improved answer utilizes exact examiner wording and real scientific reasoning. It mentions specific energy stores, kinetic and electrical, and uses powerful verbs like transfers and inducing. This completely transforms a weak, zero-mark attempt into a guaranteed full-mark response.
Okay, let's jump all the way back and finally solve that opening poll. The flawed answer says the efficiency is 0.25 because 500 divided by 2,000. Boom, marks lost. But the improved top-band answer writes the formula. Efficiency equals useful out over total in times 100. Then it substitutes the values with the units, 500 joules over 2,000 joules times 100. Finally, it provides the answer with the correct unit, 25%. This proves that substituting values, actually showing the equation, and including the percentage unit is absolutely non-negotiable. If you chose B, 25%, and wrote it out exactly like this, you secured the mark. Let's wrap this up with Section 6, your final examiner checkpoint.
Let's quickly recap this high-stakes strategy. You've got the framework, you know the hidden traps, and you understand the level of precision required. Before you ever move on to the next page of an exam, you need to run through this practical checklist. Ask yourself, have I substituted values with their correct units? Have I used exam-safe wording instead of casual language? If there's a Sankey diagram, have I double-checked the graph scales? And finally, verified the reasonableness of my answer, like making sure my efficiency isn't somehow magically over 100%.
But wait, here is the ultimate diagnostic cliffhanger. Let's say you calculated that efficiency perfectly. You checked all the boxes. But do you know what to do when the examiner suddenly asks you to evaluate the environmental impact of that power station? If you just describe or explain when the prompt strictly says evaluate, you are trapped. If you don't know the exact diagnostic criteria for the command word evaluate, you will still lose the biggest marks on the paper, regardless of how good your physics knowledge actually is.
The root cause of those lost marks is entirely based on misinterpreting Cambridge command words. To solve this exact problem and master those critical command words that decide your entire mark band, you must subscribe to our YouTube channel AC Exams at acetheexams_IGCSE to excel in your Cambridge examinations. You need to click on our next explainer right now, where we crack the code on exactly what the examiner is secretly asking you to do. Go click it, and I'll see you there.